What's up, young mathematicians? Today we're going to talk about average rate of change, abbreviated as AROC. I know we talked a little bit about this last week when we were finding key features of graphs. We're going to go further into it today. So in algebra, we often need to be able to find the average rate of change, which is just the slope of some function on different intervals. These functions may be given to you in different forms. We'll look at three different types here. These intervals might be given to you in inequality notation, maybe interval notation, or maybe verbally. So let's jump right to it. Finding A.R.O.C from a graph. You will find the corresponding y values for both the given x values, and then use the two ordered pairs and the slope formula to find average rate of change, or just find each point on the graph from the given x values and then use rise over run to determine slope. So, example 1 here, problem A, we're going to find the average rate of change of this graph on the interval given to us in interval notation 2 to 5. Remember, these intervals, no matter how they're expressed, interval notation, inequality notation, or verbally, the numbers you're given are just x values. You've got to figure out the y values that go with each of those x values. So, let's look at an x value of 2 on our graph and see what the output would be. So for an x value of 2 on our graph, the output would be right here at 8. So that gives us the ordered pair 2, 8. If we go to our graph for an x value of 5, look for where the output is. That's right here. So 5, negative 1. And we go way back to our slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that gives us negative 1 minus 8 over 5 minus 2. So we get negative 9 over 3, which simplifies down to negative 3. So the average rate of change on the interval 2 to 5 of this graph is negative 3. Now we could find that graphically. What we're doing is just finding the slope of a line that connects those two ordered pairs. And I'll start with the leftmost point and work my way to the rightmost point. So from here, I would go down 1, 2, 3, 4, 5, 6, 7, 8, and 9. That corresponds to the negative 9 in the formula. And to the right, 1, 2, 3, corresponding to the 3 in the formula. And negative 9 over 3 is still negative 3, whether you find it using rise over run or using the slope formula. All right, let's look at example 2 here. Find the average rate of change on this graph on the interval 2 to 6. All right, so we go to an input value of 2 on our graph, and we see that the graph has an output of negative 3. Go to an input of 6 on the graph and see that the graph has an output of 1. So we have two ordered pairs we could work with. I'm just going to find the slope of this line here. So from this point, I would rise 1, 2, 3, 4 and run 1, 2, 3, 4. So it gives me 4 over 4, which equals 1. So there's a couple of examples of finding A.R.O.C from a graph. Let's look at finding A.R.O.C from an equation. So what we'll do is plug both given x values in to the function to find the corresponding y values. That'll give us two ordered pairs. We'll use those two ordered pairs just like we did on example 1, problem A above, to find A.R.O.C. So finding the average rate of change of this first function on the interval negative 4 to 2. Now we could very easily plug those values in, work them out by hand. Let's go ahead and do that. Calculator could do this for us too. We'll look at that in example C. So we're plugging negative 4 into this function. So we have 2 times negative 4 minus 1 squared, then minus 4, and we're going to work that out. So we have 2, and we're going to kind of do two steps at once here. What's negative 4 minus 1? That's negative 5, and then negative 5 in the parentheses squared would be positive 25 minus 4. What's 2 times 25? That would be 50 minus 4, which gives us an output of 46. So we've essentially created an ordered pair there. When the input was -4, the output is 46. All right, now let's find f of 2. So we'll plug 2 into the same function. We have 2 times 2 minus 1 squared minus 4. And what's 2 minus 1? That's 1. What's 1 squared? That's also 1. So we have 2 times 1 here minus 4. So 2 minus 4, that gives us -2. So when the input was 2, the output was -2. So there's a second order pair, and we can now use the slope formula to find the average rate of change between these 2 points. So I'm going to use this as point 2 and this as point 1. So finding slope, m would be equal to y sub 2, which is 46, minus y sub 1, which is -2, and over x sub 2, which is -4, minus x sub 1, which is 2. Now in the numerator, that would turn to addition. So we have 48 over -6. And what's 48 divided by -6? That is -8. So the AROC of this function between -4 and 2 is -8. All right, let's look at our second example here. So we need to find the average rate of change of the function 3x minus 10 on the interval -1 to 3. Hopefully you've recognized something here. We'll talk about it at the end. So we're going to find g of -1. So that will be 3 times -1 minus 10, which is -3 minus 10, which is -13. So we have created an ordered pair here, -1, -13, and we're going to find g of 3 here. So g3, that will be 3 times 3 minus 10. That will be 9 minus 10, or -1. So when the input is 3, the output is -1. All right, so this time I think I'll call this point 2 and this point 1. So let's find that average rate of change. So m would be equal to -1 minus -13, which will turn to addition, over 3 minus -1, which will turn to addition. So that would give us -1 plus 13, 12, over 3 plus 1, 4. So the average rate of change of this function over that interval is 3. Now, hopefully you noticed that that's in the equation, so we really didn't have to do all that work. If we have a linear function, we can tell what the average rate of change is over the entirety of the function just from the m value in the formula. All right, so let's look at example C here, finding the average rate of change of 3x cubed plus 3 on the interval -2 to 2. So we could plug it in and work it out by hand like we did on A, but I want to show you how to use the calculator to do this. We haven't focused on the multi-view calculator a whole lot yet, but this calculator is extremely useful for a lot that we do in this course, especially for finding output values for different inputs of a function. So we're going to use the table function on the calculator. So click table, and I had this problem in already. Let's pretend it wasn't there. I'll clear it out. So how do we enter this problem in? We're going to click 3, and here's the x when you need a variable, and we want to raise that to the third power. So we're going to use this button here called the caret, that's C-A-R-A-T button, which will raise things to certain powers. We'll fill in the blank there with a cube. We need to get out of the exponents. We will arrow to the right and add our +3 there, and we're going to click enter, and this table says it's going to start giving us outputs at an input of 1, usually starts at 0. Let's just go ahead and tell it where we want that first output. We want the first output value at an input of -2. So I'm going to type in negative. This is the negative button here. You must distinguish that from the subtraction sign. The calculator doesn't like it if you try to use one in place of the other. So -2. We do want it to give us outputs every one whole number. You can change this to decimal values if you need to, or you could change it to a bigger step of 2 or 3 or 4 or 5, but usually we leave it at 1. Occasionally we'll change it to decimals. So we'll just hit enter a couple times until OK is highlighted, and we get our table. So at -2, we get an output of -21. All right, so we want to go back to the calculator and look and see what the output is at 2. So we will just scroll down the table here to 2, and we see that at 2 the output is 27. So we have our two ordered pairs, and we will plug those into the slope formula. I'll say this is 0.1, this is 0.2. So y sub 2 would be 27 minus y sub 1 negative 21, which would turn to addition, over x sub 2, 2 minus x sub 1 negative 2, which would turn to addition also. That gives us 48 over 4, which gives us 12. So the AROC of this function on the interval -2 to 2 is 12. All right, last we're going to take a look at finding average rate of change from a table. So we'll find our corresponding y values for both given x values, and then use the two ordered pairs and the slope formula to find AROC. So on this first table, we're going to find the average rate of change between 2 and 6. So those values are pretty easy to locate on the table. So what we have there are two ordered pairs, 225 and 638, which we could certainly plug into the slope formula. But sometimes from a table, it's pretty easy to just see what the change in y is. So what do we do to go from 25 to 38? We increase by 13. And what do we do to go from 2 to 6? We increase by 4. So remember what the slope formula is. The change in the y values goes on top, so that will be 13. And the change in x values goes on the bottom. So 13 over 4, can't simplify that anymore. There is the average rate of change of this table from 2 to 6. You could be asked the average rate of change on this table for any given interval. It could be from 1 to 2 or 1 to 3 or 1 to 3.7. So you should be prepared to do stuff like that. And last, we have a table here from a real-world problem about population increase. I'm not sure if that's for a certain state or where that's from. We treat it the same way. We're going to find the rate of change between 1980 and 2000. All right, so that's here to here. And that's probably going to give me a decimal value. Occasionally we want to turn decimals into fractions, but in this problem it would probably be useful to have this information as a decimal. So I'm going to plug this one into the calculator also. I'm going to go ahead and write it out here, but that y sub 2 would be 33.9 minus my y sub 1, 23.7. I'm going to write that over 2000 minus 1980. So x sub 2 minus x sub 1. So let's plug that into the calculator. 33.9 minus 23.7. And when we're finding slope in the calculator, we're going to use the fraction button, n over d, numerator over denominator. We have 33.9 minus, not the negative button, 23.7. And we will arrow to the bottom. I'll go ahead and subtract that in my head. 2000 minus 1980 is 20. What does that give us? 0.51. So the average rate of change between the years 1980 and 2000 is 0.51 million people per year. So there's a little bit about average rate of change.